All right, so good morning and welcome to this problem from NCRT. We are doing 3.17. Now, 3.17 is a very qualitative problem. It doesn't have values. It's not a numerical exactly, but it's more of interpretation. How you can read the graph. Okay, how you can read the graph is always very important in kinematics, or kinematics also called as motion in straight line. If you look into this problem, it's an xt graph, which is a position time graph, right? So this is the position, and it's a one-dimensional motion, which means the body is moving in either x, y, or z. Is it correct to say from the graph that the particle moves in a straight line for t less than 0? First part. The second is an parabolic path for t greater than 0. If not, suggest a suitable physical context for this graph. So we will, let me first explain you what is the, meaning of the word physical context. Physical context means in the real world, right? In the real world, example in real world, example in real world, right? So one, of course, is something like a graph, but then how does the graph, show up in the real world? What type of motion in real world, can be plotted like this graph? That's a question, right? So let's go to the question first. It says, is it correct to say from the graph that the particle moves in a straight line for t less than 0? So if you see the t less than 0, so my first problem is t less than 0. Is it correct to say that the particle moves in a straight line? Straight line. Straight line. So if we talk about straight line and t less than 0, my first problem is, how can time be negative, right? How can time be negative? T is less than 0. That is one. And second is, if you see, the time is negative, it is moving towards 0. The position of the body is not changing. There is nothing in the x-axis. X always remains equal to 0 in this negative time, which means the body is stationary. Okay, the body is stationary. However, I will add a word of caution. Time can never be negative. I don't know why NCRT has given time is less than 0. It is not possible, right? So you cannot have any physical manifestation in the world where time is less than 0. I mean, in the real world, how can you have a situation where time is less than 0? So to me, this motion in physical world is impossible, because you cannot have t less than 0. Of course, if the time is moving and progressing, you can have a stationary body, right? The position of the body does not change. My answer is no. The physical context for this type of situation is not possible, and the body is stationary in nature, even if we believe that the time is less than 0. Very strange question, part number 1, with time less than 0, which is impossible actually. Part number 2 is pertaining to this part, right, which is t is greater than 0. If you see this, this actually is a parabola, right? It is a parabola, but the question is it a parabolic path? The graph is parabolic, right? The graph is parabolic. Graph is definitely parabolic. But does it mean that the path is also parabolic? I mean, is the body also in parabola? Graph is parabolic. So let's say you have x versus t graph. Let me draw a slope and say, okay, the slope of this line, what does it represent? It represents the instantaneous velocity, v1 instantaneous, right? v1 instantaneous. This is point number A. Okay, I'm doing this deliberately to help you understand how do you decipher this graph, how do you break this graph to understand what is happening in the real world. Don't get into the trap of seeing a parabolic path and parabolic graph as the same entities. They are not. A parabolic path is different, a parabolic graph is different. Let's go ahead. Okay, If we go here, the slope, right? You can watch my playlist where I have explained what is the slope of a tangent to the graph. So this is a tangent and the slope of this is the tan theta, right? Similarly, let's talk about this. I have drawn a tangent. If you see, the slope here is high, right? This is V2. The slope or the tangent tells you the velocity. In a position time graph, what does the slope of tangent tell you? Slope of tangent, what does it tell you? It tells you the velocity. What is the slope of tangent? It's a velocity, right? So velocity 1, velocity 2, and this is the second velocity. Do you see that from A to B, the the slope has increased, which means the velocity at A point is less than the velocity at B point, which means the velocity at B is greater than velocity at A, which means this body is accelerating. Okay, it is an accelerating motion because the velocity has increased. And if you go further up like this, what is happening? You have another point C, the velocity here, which is V3 instantaneous, or is still higher. So VC is higher than VB is higher than VA. So this body is in accelerating mode. It is accelerating, right? Because the velocity is increasing per unit time. You can see from the slope, the instantaneous velocity is increasing. It is lowest here, then highest, and then the highest here. I've just taken 3 points. It shows you that this is a case of accelerated motion. Accelerated motion, right? Now, is an accelerated motion a parabolic path? Parabolic path, like it is mentioned in the question, parabolic path? No, the accelerated motion can be like this. It's a car, it accelerates in a straight line, and it may be accelerating uniformly 2 meter per second square, and it is accelerating uniformly. I've given you a simple example of but it is moving in a straight line, right? Straight line. So I would say it is moving in a straight path, right? So I hope it is making sense to you. The confusion which has been created for you is the word parabolic path. Parabolic path means the body is moving in a parabola, right? You throw the body, it goes in parabola. This is not the situation. The motion, the position versus time graph is the parabola. The path is not parabola. The path is a straight path. It's an accelerated motion. So please do not get confused by the parabolic path. Your answer should be for the second, that no, it is not correct to say that the second part of the question where t is greater than 0, t is greater than 0 is a parabolic path. Your answer is for t greater than 0, the path is a straight line, it's an accelerated motion. The graph definitely is parabola, but the path is straight line. So answer is graph is parabola. We can only anyway see graph is parabola, but the path is a straight line. This should be your answer. A lot of students get confused with this graph. Go through my video and understand the position time graph. I have given a lot of questions on the position time graph. You can see the playlist, search position time graph, search for velocity time graph, and then search for acceleration time graph. Okay, so graphs can be of any shape, but the path of the body is different, so you must be able to distinguish between the two. Please go and watch all my videos on motion in the straight line. I think there are around 70 to 80 videos you will find on this topic. This is the only channel where we are giving explanation of the situation, no application. No YouTube channel, no website is giving any application. And it's time that new generation students do not learn the old way. You cannot memorize physics. It's very important that if you want to build a strong career and you want to prosper in life, that you do all the topics, whether you are wanting to become a doctor, engineer, or whatever, with reasoning. With reasoning, you will be able to prosper very simply, you will be able to score higher. So watch this video if you are wanting to become a prosperous man, a prosperous woman, because reasoning will take you to new heights. Develop the discipline. Do not waste time. Watch videos and solutions where explanation is given. Watching solutions only will not help your career. You will forget everything. Just focus on the videos and solutions where complete explanation has been given to you. I hope you like this video. Subscribe to this channel because you never know, the next video may be more conceptual. A lot of explosive, good quality videos are coming up with a lot of explanation. This logic will stay with you for your life. Don't waste time on applications, websites, and watch solutions blindly without explanations and without understanding. Thank you very much for your time, and let's wait for another explanation driven video on physics from my side. Thank you very much.